Hello, class. These are our survey of algebra notes for comparing linear and nonlinear functions. So up until now, we have only worked with linear functions. The graph of a linear function shows a constant rate of change. So when we think of the words constant rate of change, that's really our slope. And its graph is a line. So when I say line, I mean a straight line. A nonlinear function does not have a constant rate of change, and its graph is not a line. So examples of these graphs, we could have some kind of curve. Hopefully you did some kind of warm-up that showed you a curve graph. We could have something weird like this where it's kind of pointy in the middle and it looks like two lines, or even like this, where we have like a line and then it jumps and we have a different line. And this is two different lines, right? But it's not just one line with a constant rate of change all the way through. I can't just go up 1/2 and keep making a line. So lots of different examples of nonlinear functions. So up until now, we've just been dealing with lines all the time. I don't want you to get this idea that that's what graphs always look like. So first we're going to look at tables. Look at a couple different representations, but first we'll look at tables and just see if we can tell if we are looking at a linear or nonlinear function. So remember, what we're really looking for is, do we have this constant rate of change? Do we have basically a slope here? So if I look at the first one, my x values are +3, +3, +3. So I've got a nice pattern with my x values. And then if we look at our y's, we have something similar. So with our y's, we have -8, -8, -8. So those are constant patterns. So because our x's are going up by 3 and our y's are going down by 8, that means we are going to have a slope, and this is going to be linear. And remember, when we're doing our slope, when we graphed our slope was like rise over run. So we went up and then we went over. And that up number was our change in y. And the number that we went over was our change in x. So if I wanted to write my slope as a pattern, I would put my change in y, my -8 on top. And then my x was a 3. So that would be my slope for this graph. So hopefully this is kind of all making sense and connecting back to things we already know. On the next one, it looks like we have a pattern with our x's again. Our x's are going up by 2, but let's look at our y's this time. So first my y's are jumping by 9, and then 22, and then 55. This is definitely not a constant rate, and so we would say nonlinear. So now we're going to look at some visual representations. So for this, all we have to do is simply look at the graph and decide if it's a line or not. So this first one, I definitely have a curve. And the second one, I have this horizontal line. So keyword there being line, right? Our first one will be nonlinear, and the second one will be linear. And I'd like to take it an extra step and think about what our equation is. So we are crossing our y-axis at -2, and then it's like the straight line that is like down 2 all the way, right? It's down 2 from over here, and from over here, it's always down 2. It crosses the y at -2. The equation for that is going to be y equals -2. We could also think of it in terms of y equals mx plus b. So it's crossing at the 0, -2, and my slope is 0. So if I was going to substitute this into y equals mx plus b, I'd have y equals 0x minus 2, which is just y equals -2. So I think it's good for us on these linear equations to go back and identify slope or think about an equation. It keeps those skills fresh. So looking at these examples at the bottom, they're all kind of mixed up now. We've got visual representations, we've got tables, and they're no longer telling us in the table what we're increasing or decreasing by for x's and y's. So let's go through and figure that out. So from 0 to 7, we're adding 7. And from 7 to 14, and from 14 to 21. So clearly we've got a pattern with our x's. So now let's look at the y's. So from 25 to 20, I'm going down by 5, and then down by 5, and then down by 5 again. So this one is going to be linear. And then we're going to take that extra step and identify our slope. So slope is that rise over run. So in this case, we would go down 5 units and then over 7. So my slope is -5/7. So same idea on the next one. Let's see, from 2 to 4, we're going up by 2. 4 to 6, up by 2 again. 6 to 8, up by 2. And then we can see a pattern with our x's. We've got the plus 2 every single time. That's constant. So let's take a look over here. From 8 to 4, we're subtracting 4. From 4 to 0, we're subtracting 4 again. 0 to negative 4, still minus 4. So we're going down by 4. So this one's going to be linear as well. We have a constant rate of change for both our y's and our x's. So my slope would be negative 4 over 2. This also connects back to that slope formula. So hopefully you remember slope formula. I'm going to just write it in the margin over here. Our slope formula was y2 minus y1 over x2 minus x1, which again is like the difference between my y's, what are my y's changing by, and the difference between my x's, what are my x's changing by. So that's that same kind of idea here. My y's are changing by negative 4, my x's are changing by 2, my slope is negative 4 over 2. And really we should simplify that, right? Negative 4 divided by 2 is just a negative 2. So on the last one, it really looks like it could be linear, right? I've got a straight line here, but the problem is it doesn't keep going. I don't have a constant slope. Like I can see that this slope is up 2 over 1, up 2 over 1, and I don't just keep doing that. This line has a sharp turn, and then it's going in this direction. So really it's more like 2 lines. So we would say non-linear on this last one. So hopefully this makes clear what nonlinear and linear equations are. Your homework is probably going to have a bunch of review on it as well. If you have any questions,